Hello class, this is Mr. Eggleston and this is lesson 7.3, transforming quadratic functions for algebra 1. Remember, a quadratic function, the graph of a quadratic function specifically gives you a parabola. It always gives you a parabola. Quadratics are functions that have x squared as its highest power, and whenever you have an x squared as the highest power, it produces what we call a parabola. As you've seen in our previous lessons, they look like U's. All right. And the trick is to find the vertex. And so that's what we're going to be working on. So we're going to identify the effect of specific transformation, vertical shifts, horizontal shifts, and vertical stretches. Okay, on the graph of the parent function, f of x equals x squared. Okay, and then we're going to graph the quadratic function in vertex form, which is the easiest form of the quadratic to graph. Matter of fact, with all the different ways you can write the quadratic equation, when we're asked to graph it, we're always pretty much going to turn it into vertex form by finding the vertex and understanding the behavior of the graph from the vertex. So, first, yesterday we looked at the graph of the parent function f of x equals x squared. Today we'll see how making changes to this equation affects the graph. So, it's pretty easy. F of x is just x squared. So we'll make this x squared. And then g of x is x squared plus 3. So when x is negative 4, that becomes negative 4 squared, which is 16. When x is negative 3, that's negative 3 squared, nose to the parentheses, and that equals 9. And then negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 4, 9, and 16. Then we're going to find g of x. Well, g of x is just f of x plus 3. So if f of x is 16 plus 3 is 19. F of x is 9. G of x is 12, which is 9 plus 3. F of x is 4. G of x is 7, 4 plus 3. F of x is 1, g of x is 4. F of x is 0, g of x is 3. And then it just repeats 4, 7, 12, and 19. Now they want you to graph g of x. All right, 0, 3. And unfortunately, this is by 2, so 0, 3 is right there. I did that one in blue. And then 1, 4. Wait. 0, 3 right there. 1, 4 is right here. Notice it's on both sides. 2, 5. 2, 7. 6, 7. 3, 12. And last but not least, 4, 19. And here is the graph of g of x. Okay, and it's a parabola. Graphing just x squared, just so we can see the difference, we start at 0, 1, 1, 2, 4, 3, 9, 4, 16. Unfortunately, I'm a little bit off on the right there. And so we have a graph that looks like this. Okay, and the white is x squared, and the green is x squared plus 3. Notice, okay, I forgot to write this. How do the values of g and f compare? Well, g of x is always 3 more than f of x. And the graph, you see that g of x, is shifted. The math word is translated up 3 units. Notice the shape of the actual shape of the parabola is the same. That is, from the vertex, we go over 1. 1 squared is 1, we go up 1. Over 1, 2. 2 squared is 4, we go up 2, 4. Over 3, 1, 2, 3. 3 squared is 9. We go up 1, 3, 5, 7, 9. And so it's the same as just your x squared graph, just shifted up 3 units. So the trick is to always find that vertex location. What is the vertex? I'm glad you asked. 0, 3. As compared to the white of 0, 0. Notice the y value shifted up 3 units. What is the axis of symmetry of G? Well, the axis of symmetry is just x equals 0, because it's the x value of the vertex. Identify the domain and range of G. Well, the domain is going to be all reals. That's always the case for parabolas, for quadratics. And the range, which is the output, is y is greater than or equal to 3, which is the y value of the vertex, because the graph is above it. Predict what you think would happen if we graphed the function y equals x squared minus 3. Well, you notice x squared plus 3 shifted the graph up to 3 units. So minus 3 is going to shift the graph down to 3 units. All right? Everything else would be the same. So what would happen is the parabola would move down 3 units. Okay. And there you go. So, couple things. Up here, it's a vertical shift up 3. This is equals x squared plus k, vertical shift k units. And the fact that this is minus 3 is a vertical shift down 3 units. Okay, and there you go. Now they say complete the table of values and graph h of x for h of x equal to 2x squared. So this is 2x squared. So when x is 0, that'll be 2 times 0 squared, which is 0. When x is 1, that's 2 times 1 squared. Well, remember your orders of ops. When you're evaluating something like this, the first thing you're going to do is evaluate the thing that's raised to the second power. So 1 squared is 1 times 2 gives you 2. And then when x is 2, that will be 2 times 2 squared. Well, 2 squared is 4 times 2 is 8. First you square, then you multiply it by the number in front. So now it's 0 to 8. When x is 3, that'll be 2 times 3 squared. Well, 3 squared is 9. Okay, again, orders of ops. Evaluate 3 squared. 3 squared is 9 times 2 is 18. Okay, and when x is 4, that'll be 2 times 4 squared. Well, 4 squared is 16 times 2 is 32. So let's go ahead and plot this. 0, 0, 1, 2. 2 is halfway between 0 and 4. 3, or 2, 8. 2, 8. 3, 18. Here's 16. 18's halfway between 16 and 20. And 4, 32. Which is right there. All right. Now, that's understanding that our vertex is right here at 0, 0. And knowing that symmetric on either side on our axis of symmetry is the AOS is x equals 0, we can just plot the other points. So it will be 2 here, 8 at x equals -2, 18 at x equals -3, and 32 at x equals -4. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3. 1, 2, 1, 2. 1, 1. And this is it going to snap? I guess not. And this is the parabola. Okay. Now compare that to the original where you go over 1, up 1, over 2, up 4, over 3, up 9, 2, 4, 8, 9, over 4, up 16, and it looks something like that. And the same idea on the other side. And you see that the 2 stretches. 2 stretches the graph, the parabola, by a factor of 2. Okay. The vertex and axis of symmetry, I already identified it. 0, 0, x equal to 0. What is the domain and range of h? Domain, all reals. And the range is y. I guess I could say h of x is greater than or equal to 0. Explain how the coefficient of 2 affected the graph. It stretched x squared vertically, that's up and down, by a factor of 2. Okay? So you see when there's a number multiplying, notice on the original graph, we start at 0, we go over 1, and we go up 1, which is a quarter of the way. We go over 1, 2. 2 squared is 4. We go up 4. Over 3. 3 squared is 9. We go up 2 or 4, 8, 9. And so forth. And the yellow is we go over 1. 1 squared is 1. Multiplied by 2, we go up 2. We go over 1, 2. 2 squared is 4. Multiplied by 2, we go up 8. So you can use the counting concept, over 1, up 1, over 2, up 4, over 3, up 9, because we're from the vertex. And then once we go over 1, square it, and then we multiply by the number in front of the x squared. In this case, it was a 2, so we doubled it. All right. Now they said go to Desmos and click Graphing Calculator and graph x minus 4 squared and sketch it to the right. Okay. Here I gave you the graph of x squared, and now here's the graph of x minus 4 squared. Notice that is just the x squared graph shifted to the right 4 units. All right, the vertex of the original is 0, 0. The vertex of the red is 4, 0. Okay, so it moves it to the right 4 units. And if you look, you can see that if you go over 1, up 1, right? Over 1, up 1. Over 2, up 4. Over 3, you go up 9. And it's the same thing here. If we, come on, select it. So if we go over 1, we go up 1. If I can get there. Over 2, which puts us to 7, we go up 4. Okay, and so forth. So the shape does not change. It just physically picked up the graph and moved it. All right, so we're going to sketch that on here. So, and then from here to the right 1, square it, up 1. To the right 1, 2, 3, excuse me, to the right 1, 2, up 4. 2 squared is 4, 1, 2, 3, 4. To the right, 1, 2, 3. 3 squared is 9. We go up. Oh my gosh. I forgot this is scaled by 2s. Gosh darn it. Okay. So we start at 0, 4. Or 4, 0, excuse me. We go over 1. 1 squared is 1. We go up 1. We go over 1, 2. 2 squared is 4. We go up 4. We go over 1, 2, 3. 3 squared is 9. We go up 9. 2, 4, 6, 8, 9. All right, and we go in both directions. Okay. You could plug 3 in, and you see 3 minus 4 squared is 1. Or 3 minus 4 is 1. Squared, it's still 1, so that puts us right where I was. When x is 2, 2 minus 4 is negative 2. Squared is 4. And when x is 1, 1 minus 4 is negative 3, squared is 9. So if we went to the right, 1, 2, 3, 4, 4 squared is 16, we go up 16, which would be at the very top there. And so you would just connect it with a nice parabolic curve. And there you go. Okay. The vertex is at 4 comma 0. The axis of symmetry is x equals 4. Was the domain and range? The domain is all real numbers. And the range is y is greater than or equal to 0 because it's above the x-axis. All right? So I want to show you that as long as if we change things, like if we change that to a 1, notice the graph is shifted to the right 1. X minus 1 shifts the graph to the right 1. Everything else is the same. If we change that to 6, it shifted the graph to the right 6. Notice x minus 6 shifts it to the right 6. What do you think would shift it to the left? Well, instead of minus 6, if we make that plus 6, notice now it's shifted to the left. So that's how you can tell in which direction the graph shifts. Or in math language, translates. And remember, your x's are liars. So if it's x plus 6, it shifts to the left 6. X minus 6, it shifts to the right 6. Okay? So if h of x equals x plus 3 squared, without graphing, can you predict the vertex and axis of symmetry of this parabola? Yes. The vertex is going to be at negative 3 comma 0 because it's to the left 3 because your x's are liars. Okay. And the axis of symmetry would just be x equals negative 3, the x value of the vertex. Can you predict the domain and range? Well, yeah, the domain, like with all parabolas, and quite honestly, all polynomial graphs, the domain is all real numbers. Which can be represented by that. The range would be y is greater than or equal to 0. Okay? And if you wanted to graph it on Desmos, x plus 3 okay. You see the graph is shifted to the left 3 units. All right? So we were right. Okay? Now, what do you think's going to happen if we try to graph this? X minus 4 quantity squared plus 3. Notice, now you have numbers holding hands with the x and being added to the outside. Well, remembering your x's are liars, you know that x minus 4 means the graph is shifted right because it has to be in the opposite direction of negative 4. Shifted right 4 units. And because of the plus 3 on the outside, and up 3 units. Okay, so the vertex is going to be at 4 comma 3. How do you know? Because that's how the behavior of the graph. How do you know? Because x minus 4 gives us shift right 4 units. And the plus 3 on the outside shifts us up 3 units. Okay. And they want us to graph this using Desmos. So it was x minus 4 and then plus 3. And there's the graph. All right, notice the vertex is at 4, 3. Okay. Graph, okay, see if you're correct. So we were correct. So here it is. The parent function y equals x squared can be shifted vertically or horizontally or stretched. This affects the vertex and the range. Y equals x squared plus k is a vertical shift of k units. K greater than 0 shifts up. K less than 0 shifts down. X minus h is horizontal shift of h units. H greater than 0 shifts right. Notice it's going to be x minus a number. Shifts, let's say 4, shifts right 4 units. And if it was x minus a negative 4, which is x plus 4, shifts left 4 units. Okay? Your x's are liars. They're lying to you. And then y equals ax squared is a vertical stretch or shrink. If a is greater than 1, it's a stretch. And if a is smaller than 1, the size of a is smaller than 1, it shrinks it. Okay? And there you go. Combines multiple transformations. So here's the vertex form that you should just get used to. It's the easiest thing to graph is when it's in the vertex form because you know where the vertex is. And you know the A will vertically shrink or stretch it. And you know where the vertex is and the axis of symmetry. So the vertex form you're going to find out is the easiest thing to graph. All right, that's it. Have a great day.